So the integrated rate law expresses how the concentration depends on time. The previous rate law that we've talked about is concentration and rate. So we know it's integrated if it's concentration and time. First order is ln of concentration equals negative kT plus ln of concentration. This one is also on your formula chart, but on your formula chart it's not written in this format. It looks like so. I've written it the way that I did on the board because it's now in y equals mx plus b format. And so my y axis is ln of a, my x should be time, slope is negative k. So make sure that you write this graph on your paper. So a plot of ln of concentration versus time, if it gives you a straight line, you know it's first order. The slope is going to equal negative k. So if you have the graph or the data, you can determine your k from the slope. Half-life is the time it takes for 1/2 of a substance to react or to decay. In this problem, we have 0.1, and then half of 0.1 is 0.05, and then half of that is 0.05, and so on. So the time it takes to go from 0.1 to 0.05 was 100 seconds. Then to go from 0.05 to 0.025 is another 100 seconds. Notice it keeps going down by 1/2 every 100 seconds. So the half-life, or T1/2, is 100 seconds. This is a first-order graph because half-life is constant. Every 100 seconds, the amount goes down by 1/2, which proves it's first order. First-order reactions you can solve for the half-life using this equation. So T1/2, which stands for half-life time. You don't divide or anything like that. That's one constant, or not constant, but one variable. So T1/2 is equal to 0.693 over K. And then K would have the units of 1 over time because it's first order still. It's the same first order that we've been talking about, which means the units of K have to be the same as they were before. Go ahead and pause the video and figure out the answer to these 3 questions. Restart when you have your answer. So the first thing you should have done is said you had 80, 40, 20, 10. To go from 80 to 40, it took 2 days, and then another 2 days, and then another 2 days. So the half-life is 2 days, which means this order must be first order because the half-life was constant at 2 days. To figure out the value of the rate constant, we can use this equation. But we're solving for K, so rearranging that equation, we get this. So K is equal to 0.693 over 2. So K is equal to 0.351 over days. You also could have said days -1. On this problem, reading the problem, you'll see that it's first order. Always read the problem. Sometimes they'll tell you what order it is. You don't have to look at a graph. So go ahead and pause the video and solve for A using the information provided. So you should have plugged in your 20 minutes. Solving for K, you get 0.035. And this was in minutes, so 1 over minutes. All right, on B it says how much time is required for this reaction to take place. Remember, time and concentration is integrated rate law, and since it's first order, we're going to plug in our values into the integrated first order reaction. So we know what our K value is because we just solved for it. Our time is what we're looking for. And we're dealing with percent. Since we're dealing with percent, we're going to start with 100. You always start with 100%. And since it's 75% complete, that means we have 25% left. So down here is going to be ln of 25. To solve that in the calculator, we're going to do ln of 25. The ln button's next to the 4. So ln 25 minus ln 100, and then divide by negative 0.035. So our time is equal to 40 minutes. It's got to be in minutes because our K was in minutes before. Always double check that your K and T units are matching up time-wise. If K was in seconds and I needed time in minutes, I would have to convert those. So go ahead and pause the video and try this one on your own. Restart when you have your answer. If you got A, then you are correct and you can fast forward. If you did not get A, then continue watching to see where you messed up. So it was a first order reaction. They gave us the K and they gave us the initial amount. Remember that this little 0 means initial. And we're looking for the final concentration. My K was in seconds, and then this is in minutes. So that's 120 seconds. So the first thing I want to do is solve everything on the right side since my variable's not over there. So plugging it into the calculator, you get negative 0.893. But I need to get rid of the ln now. So second ln is the E. So E to the negative 0.893 gives me my concentration, which is equal to 0.409 molarity. Go ahead and pause the video and try this one on your own. Restart when you have your answer. This one was 18. And since we were talking about days, it had to be 18 days, not 18 hours. If you got that one, then you can go ahead and fast forward. If not, continue watching to see where you messed up. So again, this one was also first order. They said that the drug can be sold until 20% of the original drug has undergone a change, which means 80% should still be good. So 20% is turned into something else, 80% is still the drug that was purchased. Our K is given in the problem. We're looking for time, and our initial amount was 100 because we're dealing with percents. So ln 80 minus ln 100 divided by negative 1.25 times 10 to the negative 2 is 17.9 days. Going to write down second order rate law. Notice this one looks almost exactly the same as first order, except it's 1 over concentrations versus ln of concentrations. So for my graph, I would have time still on the x, and I'd have 1 over concentration on the y. Notice my k is positive, so my slope is positive.
Good afternoon, Tigers. Here's some signaling announcements. From Ms. West, do you need community service hours? Is a perfect.
This is the half-life equation for second order. It's not on your formula chart, but it also won't be on any test or quiz. Here's the zero order rate law. So this one, again, looks just like the others, except it's going to be concentration instead of ln or 1 over concentration. For your graph, you should still have time on the bottom and then just regular concentration. And it's going to have a negative slope. So slope is equal to negative k from the equation. Zero order half-life is this one. Again, this one's not on your formula chart, nor will it be on a test or quiz. So your questions are going to look like these, where you're given some data and we have some graphs. So this graph would be zero order if it was straight. This one would be first order. This one would be first order, and this one would be second order. I'm getting that from my axes. So we look, and the only one that's straight is this graph, which tells me that the order must be first order. So my rate law, I'm going to write rate equals K, and then my substance is H2O2, and it's to the first order. So I can leave it or put a 1 there. Integrated rate law, because it's first order, is going to be ln of concentration, which is H2O2. So plug in what it actually is, equals negative KT plus ln of initial concentration. From the data and my graph, I can find the value of the rate constant. Remember that slope is equal to negative k. And then slope is equal to y2 minus y1, x2 minus x1. It doesn't matter which two variables which two times and concentrations you use, but choose ones that are spread out. So I'm going to use this one and this one. For my y, I didn't plug in concentration. I used ln of concentration. So it should be ln of 0.050 minus ln of 0.37. And again, I just chose 2 of them. I could have chose the first and last one, or at 0 seconds and 600 seconds. They just shouldn't be right next to each other. And then for x2 was 3,600 seconds minus 1,200 seconds. Plugging that in, I get slope is equal to negative 8.34 times 10 to the negative 4th. So k is equal to 8.34 times 10 to the negative 4th. Since this was first order, my units on k are 1 over time, which is 1 over seconds. Notice on this one, we're talking concentration and time, which tells me that I'm going to have to use my integrated rate law. And since it's first order, I use the first order integrated rate law equation. So I'm trying to find what my final concentration is. I know what K is because I just solved for it in the previous problem. Make sure that you plug in that negative because in the equation it has a negative there. My chart is in seconds. This one's in seconds, so I can just plug in 4,000. And the place people get confused is initial concentration. You know initial because it was right here. So my initial concentration is 1. You're always getting that from the chart if it's provided, or from the graph. You would have to read it from here. So now we can just plug in. If I plug in everything on the right, I get negative 3.336. And remember, to get rid of ln, you raise it to the power of e. So e to negative 3.336. And I'm solving for concentration, which is molarity. So this one is first order. So since I'm trying to solve for half-life, I can use the first order half-life equation. We know K because we solved for K back in C. And so dividing those, we get 831. Our time's in seconds, so it's seconds here as well. Go ahead and try A and B on your own. Restart when you have your answer. So this one is the straightest line. This one kind of looks like it to be straight, but it starts curving down at the end. So out of those two, this one is the straightest one. And then this one's definitely curved. So we know that it's second order. So rate equals K NO2 to the second. Since it's second order, the integrated would be 1 over NO2 equals negative KT plus 1 over initial. All right, now you should be able to solve the rest of these. Go ahead and try solving C, restart when you have C. So on this one, since it was second order, slope equaled K. So you could could have taken any of the two. I chose those two. And remember that you want 1 over concentration since it's second order, because our Y values are 1 over concentration. Plugging it in, I got 2.08 times 10 to the negative 4th. If you chose two different ones, you may not get the exact same answer, but you should get a very close answer. And since it's second order, your units on K should be 1 over molarity times time, which is seconds. Go ahead and pause the video and do D, restart when you have your answer. So it's second order, so you should be plugging it all into the second order integrated rate law. We know K from the previous problem. They gave us time, and our K and time units match, so we're good. And then initial, remember we're always pulling it from up there. So plugging it in, you get 1 over concentration is equal to 7.616. So concentration is equal to 1 over 7.616, which is 0.131 molarity. Last one, go ahead and solve E, restart when you have your answer. So this one, we are still using second order. They gave us the final concentration. Our K is still from C, but we're looking for time. And our initial, still from the beginning. So subtracting and then dividing by K, you should have got it. .94 times 10 to the 4th seconds.